My name is Ciprian Tibia, and I will be your host for today. This course is, of course, about Introduction to FEM-Design, as you all know, and it's addressed to new people or people who had limited interaction with our software. But before we dive into that, I would take this opportunity and tell you a little bit about our company, about our software that we are offering, and then we will dive into the webinar part. So we at StruSoft have a very large array of software. And as you can see, in terms of structural, we have FEM-Design, which we will be discussing today. We have the matrix software. Then we got some element design software like WinStatic, Simplex Beam, Simplex Foundation, Simplex Column Soon, IGI. Then we have software tailor-made for pre-stress elements, which is, of course, pre-stress. And we also have a package for BIM called Impact, and that is like tailor-made for precast structures and factories and transports and so on. So yeah, one more thing. There is a very big and nice upcoming webinar about Eurocode Gen 2, and it will take place on June 11th. So make sure to save your spot, as this one is going to be very popular, and I think it's going to be like limited places in terms that we will reach the higher ceiling of registrants. All right, so today we will be talking about FEM-Design, and I would like to start with the user interface, of course. And the user interface, but maybe before we do that, let's start with the very beginning, and which is the selection of the code or national annex, which of course can have a very impactful influence about the material library for steel, concrete, reinforcement, and timber, the automatic combination of load cases and load groups, the design parameters, and crack weight calculations. So if you just want to use plain Eurocode, just select the first one. If you would like to use the national annex, be aware of those changes. All right. So then we are greeted by this user interface, which, as I was saying before, is divided into tabs. Now, in terms of those tabs that you can see here, we follow the principle from left to right, but they are divided like the input tabs and the design tabs. So up till the finite element tab, we call them the input tabs, and from the analysis onwards, we call them the design tabs. And there, of course, we can add the documentation as well, which is a separate one. All right, now this is our, of course, our model space where we will have our structure. In the right part, we have like the layer settings and the filter palette, and we will be able to see the results and yeah, do a lot of things from this quick toolbar. Then in the left side, we have those quick buttons, we call them, where you can measure, you can do additional structures to help you modeling, a lot of things. So I won't go into the very detail of every single button, but those are the quick buttons. Then, of course, we got the command line, which is here at the bottom, and the snap settings, which are in the right bottom corner. Now, keeping this in mind, we can then move to, speaking a little bit about the coordinate systems. So as you see here, we got a global coordinate system, but then again, we can have like a user-defined system. We also have like element, own coordinate system. And yeah, then if we go and move a little bit to like the very design of the building, we are first greeted by this story button. Now, as the name suggests, of course, this is the place where we can define our stories, and also give like some dimensions in terms of the size of the building. So let's say that my building is, I don't know, 20 by 20, right? And bottommost level is yeah, 0. And then we click insert button in order to insert as many stories as we want. So in this case, let's say, I don't know, 3 stories, 4 stories, something like that. And of course, by default, FEM-Design implements this height of 3 meters, but of course, this can be modified. So I can do like the bottom floor to be a little bit higher. And yeah, the rest of the floors can stay like this. Okay, then we click apply, okay, and we are finished with our stories. Of course, if we like to hide them for the moment, we can just go in the layer and hide them. They are still there, but they are hidden and locked. Right, then the next one is the copy story, but this one we will use a little bit further down the line. The third one is the axis. Now, in terms of axis, of course, I can select number of letter to be, the index. And let's say that for the, X direction, we select the number, and for the Y direction, we select letters. So we can define the axis like this: 1x, I don't know, 4 meter, then 2x 5 meter, then 1x 4 meter. And of course, we can draw them like this. Right, so maybe I shouldn't have closed the stories, but yeah, pretty much okay. All right, then we said that for the other one, we go with letters, and we can say 4x 4, for example. And we go from this direction, and we defined our axis. So now we got axis. Of course, we need to model some elements. So let's start with some columns. When this column window opens, I see that the placement here can be set to, above, below, and I have this big button with default settings, which I'm going to click. And as soon as I click it, I'm greeted by this, new window for the column, where I can set the rotation of the column if I want to. I can, use the 6 degree of freedom, 7 degree of freedom. But the most important part in this first stage would be to select what type of column do I want to have. So let's say I want to go with a square column, and I don't know, 30, and then I'm going to go with the material, and of course move it from the steel to the concrete. And here I can either select these reduction factors or not. And here I can use the creep factors. I can use the shrinkage factor, or of course, I don't need to if I don't want to, but yeah. And here I can modify the stiffness and the end condition. Now, we will not modify the end condition for this column. We will just leave it with the default setting. So now I'm moving to place the column, and I'm just going to place it at the intersection, right? But I see that the height is wrong, so I'm just going to switch it to 3.5 meters. All right. Then let's say that I just want a full row of columns in every X. And I can either move to copy them to the next one, or I can move to the beams and copy them afterwards and just complete the beams in the other direction. Now, I will just copy them because I would like to have a little bit more room to improvise and have some columns which are not connected to any beams. So we will have a little bit of a punching shear as well. I forgot to tell you about this selection window. So the selection window is like in AutoCAD. If you do this, it will just select the elements in the box, right? But if you do like this, it will select everything which is intersected. All right, and now I have selected my columns, and I want to copy them. So I will specify the copy point to be at the bottom, and I will just move them to the other axis intersection. All right, now I have my columns. Probably I'm going to delete some of them, but yeah, we'll see about that. Yeah, the next thing will be to add some beams. So we can do the same. We go to the default settings. We choose some sections. Again, I'm going to the concrete part. I'm going to the rectangle, and I don't know, 120 by 300, and the material C40, and the end condition I would like to be hinged. Right, so I specify that I have the same end condition at both ends, and now I can move and design my beam. Please note that this model was not prepared, so I might exaggerate or minimize some of the sections. It's just an academic model in order for you guys to make an idea about how to design in FEM-Design. So it's not a real project. All right. And then let's place a staircase somewhere and delete this one and this one. All right. Now, of course, I can help myself by adding another axis, or I can just see, okay, what is the distance between 2 axes or 2 columns, it's 5 meters, all right, then probably I would like to have an entrance like 2.5 meters. So yeah, I can just copy this one and say here at 2.5, 0. All right, and now I can make like a staircase. And the way we do it, we go to the plane wall. So you see, here is like line elements, and then it's shell elements, of course, like plates, and then walls. If I go here again, I will have to select the height, was 3.5, right? And then the thickness. And we will just leave it by default with 0.2 thickness. And also we're gonna design it as above. So let's design it like this. Yep. And now I have to make an entrance. So I'm just gonna select this small button here, which says hole. I'm gonna click my wall in where I want to make the hole into. And I'm gonna say 0 point, let's see, how wide was it? Maybe I have to measure it first. So 2.5, I will make a door of 1 meter, that is 0.75 in each part. Okay. So yes, 0.75. All right. And then I will say at 1, that 2. And then it made a door which is 2 meters high and 1 meter wide. So this is how we create the holes in the walls. All right, good. Now, the next step that I would like to do is adding a plate. Now, I can do that here with the plain plate. And of course, I can look into the settings if I want to, and I should check the thickness, which I would leave as well as default at 0.2. And I will just add my plate. Okay, now I have my columns, I have my beams or some beams, and of course I have the plate, but I'm missing the supports. Now I can either go and copy the story now, or I can, add some loads and copy it later. So let's go and use the copy story now, so we see how it works for the geometry. Just note that you can copy the loads as well. So we select the source as being the story 1, right? And we want to copy at story 2. And if I check this checkbox, it will copy the loads also, but in this case we have no loads. So please note that he shrinked the height of the floor automatically to 3 meters, even though the first floor was 3.5 meters. So yes. So is that easy to just define a full building? Of course, I can, switch off the transparent view, switch on the 3D model viewer, and just visually inspect if I did something wrong or not, and then I can go back and continue modeling. Now, in terms of I can also hide my access now. In terms of support, I can go here at point support group, and all I need to do is, select the lateral view and just go with the box selection, and all my columns are now supported. And in the same way, I will do it for the line support group. I will go down, and now I have my line support. Okay. So looking at the building, we can say that, all right, my structural elements are in place. I can move to the load parts. So of course, we are going to come back, because during this session, we will also cover the snow, wind load, and we will need some covers, but we are going to come back to that a little bit later. So going in the loads tab, the first button, of course, is load cases. And here I will have to define my loads. So I will just, do something really easy. I will select the permanent load and the live load. And, it's like long term. Okay. Or we can leave it as permanent as well. Doesn't really matter. And now I can, the next step will be to add the loads. Now, in order to keep things simple, we will just add some surface loads, and let's say 10. Okay, 1, 2, 4. And then we switch to the live loads, and we add something like 6. Of course, one small thing that I forgot to do, and maybe I should do it so my building will look okay. I forgot to do the cutouts, and I will have to do it 4 times now in the plate. Otherwise, our staircase / elevator case will have plates in between stores. So yeah, I can use this one story up tool and do it a little bit easier from a viewpoint. Yeah, and now I'm just gonna select the holes and then move to the next one. Normally, I should have only made this once, but now I had to make it a little bit, yeah, more times. So now we are okay, and yeah, we can return to our loads. So we were in the live load, which was 6. Okay, and then we move to permanent load, which was 10. All right, now we have our loads, and or at least some of them. All right, the next button is, of course, the copy load case. Then construction stages, if I want to do a construction stage analysis. And this is like a good idea for a next webinar. And yeah, the load rules. So what are those load rules? If I define the load group, with the safety factors, with the very type of load and etc., I am able to generate automatic load combinations. So we just leave it like LG1, load group 1, and we drag and drop the permanent loads. And here I see that type is permanent, standard combination, safety factors, C value, everything is here. Then I could walk and add the load group 2, do the same thing for the live loads, and make it like a temporary, right? And yeah, here of course I can use the different values depending on the type of building that I have. All right. We are missing 2 load groups, but they will come a little bit later. As you see here is like wind and snow. Okay. Then we said that we want to do a wind and snow load definition. Now, we will need to use covers in order for the software to understand what is the internal structure and what is the external structure. I need to do this, and I can do it easily on the entire structure, which I guess it was 3.5 plus 3, 12.5. Yep. And I can just do it like this. And you see the surface was automatically divided to each supporting member. And that's the surface that will be transferred to each supporting member. Yeah. All right. And let's do one for the roof. Good. Okay. Now, let me see what's happening here. Okay. All right. So moving further to the loads tab, we have to define, as I said, the climatic covers and or load panels. So basically what we need to do here is just select this one with the right click and then left click on the outside. Right click selection, left click on the outside. And again. And one more. Oops. Yeah. And then I'm going to the roof part. And I have a flat roof in this case, and I'm just going to specify like a wind direction like this. Okay. Don't know if everything is connected to the top side, but hopefully it is. Okay. Then we need to define our wind. And yeah, those are the generic position of the building, if whether it's placed on the sea or in a very urban area surrounded by other tall buildings, and of course it will have an impact on the wind factor. But I don't want it like this. Sorry, I want it as because if I do it like the generic building, it will transfer the wind loads only to the at the plate level as a uniformly distributed load. But I wanted to be like on a surface level. So now it looks like okay. Yeah. All right. Good. So I have all the wind cases, different directions generated automatically. And I can do the same for the snow. And yeah, just generate the snow. Of course, I will have to make sure that I'm in the right area with the right factors. And afterwards, I can just click OK, and it will generate a snow load. In this case, it's a very simple snow load as it is a flat roof. But FEM-Design can handle also, different levels of roofs and snow agglomeration and stuff like that. So yeah, and now I have all my loads, and if I go in the loads group, I see that the wind and snow was created as well. So the next thing would be to go to load combination. Now, in this load combination window, of course, I can do the manual combination if I like, or I can, just skip altogether and generate the load combinations. And yeah, it made like, let's see, 230 different load combinations. So of course I can limit that to a smaller number, but just for the sake of the example, I made all of them. All right. Yes. Then I can visualize the finite element, and I can generate it, and or I can play with the size of the average finite element, but that will be done automatically, in the next phase. So I can just skip this phase altogether and move to the next one. The reason why this phase is important is because if you are used to finite element modeling, probably in other software, or you remember from the university, the more refined the mesh is, the more computational time it will take. So it's up to us as engineers to find a good balance in terms of calculus accuracy versus time spent. And in that regard, we have one of our colleagues has developed a few years ago a very nice tool that automation that will basically tell you which is the optimal mesh size. And for those of you who are interested, just send me an email, and I will send it. I will send the commands to you and how to do it. Okay. Then, as I said, we can go and skip directly to the analysis part. And if we click on this calculator, which is the first button, we are greeted by this window, which is the calculation window. Now, of course, here, I can have midpoints or, just corner points. This is up to you. It will impact the computational time, of course, because there will be more equations, but that's totally your choice. All right, and I will just select, like the load combination and load cases. And if I click this button, I can select what type of analysis do I want FEM-Design to perform for each combination. So, of course, here I can go and select nonlinear elastic, plastic, crack analysis, second order imperfection, and so on. So, yeah, okay. We'll just click OK. And now FEM-Design has automatically generated the mesh, and now it's calculating the model. Of course, the model will take probably a little bit longer as there are a lot of combinations, as you saw, but it shouldn't be like an insane amount of time, judging that we don't have such a large model. Yeah, so going back to what I was about to tell you and told you actually partially, is that there is a way to determine which is the optimal mesh size, where the gain in terms of accuracy is too small, but the computational time is far longer if you go past that point. I'm trying to remember if I forgot to tell you something. Yes. Of course, you have a lot of visualize options, and I will show you after the calculation is done, and we can go to the results. Basically, what you can do is create your own color scheme. So I don't know, for example, you hate color red or color blue, and you only want other colors in your model. You can do that by using this color scheme, which, of course, as I said, you can save as a default, and you can upload to all of your models without having to redo it every time. And it's quite nice. We each have our own preferences in terms of how we like to view a model. Yeah, then yes, so once this calculation will be done and we will go to the results, the next step to the design of the elements. And I will just take advantage. Oh, I wanted to see if whether we have some questions. All right. So as I mentioned in the beginning, here I can quickly view the results, and I can go load combination by load combination, or I can go maximum of load combination. That's up to me. So let's see if I go to load combination and I want to see in combination number 1, I want to see the displacements. So now I'm able to visualize the displacements. Of course, I can, quickly go and select a point and add a result, or I can place this one, which is the automatic numeric value. I can do a numeric value like this, and it selected all the points, and yeah. I could do the min-max in absolute form. So there are a lot of ways how I can view the results. I can animate them if I like to. Yeah, I can, of course, use color palette if I don't like this, deformed shape. So here are a very vast array of options to visualize the results. Of course, I can go to the reactions and see the reactions. Yeah. Then the bar forces, shell internal forces, and so on. So basically, this is the place where I can visualize, check, and decide if whether I got a good design or not. Okay, then the next thing that we are going to do is go maybe I should spend a little bit more time to go into the results, or I don't know. Let's look a little bit at the questions, as I say. So how do we ensure the connectivity? Well, of course, we can see that in the finite element. So if I go in the finite element and I don't, see like a very, let me just hide this one. Covers. Yes. So I can quickly see in the finite elements if an element, is misplaced or disconnected, and probably, if I just place like an overlapping wall or something like that, it will make like a very fine mesh in that area. And this is like the automatic peak smoothing that you see here with the circles. So in order to normalize the unrealistic results, because this is like a simplified model where our column is just a bar element. But there is another way how to tell if whether you connected them. When you build your geometry, this symbol will appear. It's about how you define your snap settings, because you can define your snap settings to snap from element to element, and then you can make sure that you connected all the elements in the right place. Yeah. So I hope that answered the question. I will go through the remainder of the questions at the end of the session, the one that we can cover, and I will take randomly, and the ones that I cannot cover, I will just ask you to please send me an email, and we can schedule like a very short Teams call where I can show you directly how to solve your question, or just answer if it's something verbal. Okay, then let's move further to the concrete part. And here, if I calculate again, I have the option to design calculation, and I can check, or I can auto design. We can, let's do the auto design. Hope it and we can go through some of the questions. How can you copy columns or walls from one level to another with different floor heights? What is the easiest way error-free? Well, I just showed you guys how to copy an entire flow, but if you just would like one element, then I guess it's easier to just design it at a different height. But if you want, where is a multitude elements, like it can be hundreds of elements in a flow, I think that the copy story has its advantage there. But of course, you can trim it down. If you want to do your own load combination, how to set that up. I will show you after the calculus is performed. Basically, where you saw that we generated the load combination. Basically, if you go at the end of the load combination, or you will have an empty table, right? You can just say a name, load combination number 1, and then the next column, it will be like the safety factor, and the next one, you will select from a drop-down menu the load, and then you go on the safety factor column beneath it, and you select the next safety factor and the next load, and so on and so forth. So that's how you manually input your own combination. Let's see another one. Let's see this one. Only some vertical elements, not if we wish to copy different story, a different height. Yeah, so the copy function will automatically, work, and it will resize the elements, the copy story, if you select an entire story. Of course, when building geometry, I can do it like in 7 different ways probably. So it's exactly like in AutoCAD or Tekla or whatever. There is a multitude way how you design geometry. Kindly provide the name of the analytical software utilized along with the corresponding download link. So Softa, this is FEM-Design, and you will find all the necessary links on our website. Yeah. And, you will be sure that you can handle it from there. Can you maybe show how to use foundation design? Well, foundation design, yes, I can, but we don't have enough time now, because basically when you go in the infrastructure part, we got more ways how to do it. Probably you saw that we have soil modeling as well. And when you use 3D soil, maybe it auto. Hopefully, yeah, break the process. Break. Okay. So I was saying about the foundation design. Now, the foundation design is used, we normally use it in collaboration with 3D soil, and it's a little bit more complex. We have to define a soil, then we have to define the foundation and so on. So it's a different topic, let's say, which I will not cover in this webinar. But if you are interested in foundation design, please either go to YouTube, where we have all our recorded webinars, or in GoToStage. And I'm pretty sure that you will find at least 2 or 3 webinars which treat the foundation and soil, yeah, as a topic. Okay, so let's go flow by flow. So I interrupted the process as it took a little bit more time. So you see, this is the punching reinforcement that we discussed. That basically I wanted to, you guys to see. And all right, let's see what says here. Yeah, it used 134%, so probably our loads were a little bit too high. I mean, not probably, for sure. Okay, design. Yeah, it will do the same. Yeah, so in this case, it's a little bit tricky, as I would have to redo the analysis or either increase the thickness of the slab or decrease a little bit the loads, because it seems it's overkill in terms of punching shear. All right, let's go to bar and let's design this one. Okay, now we have this one designed. Good. Let's go to the results. And if I click on the magnify glass, right, is the detailed result. So you saw me going into the results in the RC bar, and I click the utilization, and then I use the magnifier glass, and now I'm coming here to the column, and I'm just gonna click it, and I get this calculation, detailed result, where I can see all the calculations that were made. And if I want to, maybe do some modifications to the proposed reinforcement, or just leave it as it is, that's up to me. I can, either go to documentation or, yeah. So I can do the same for the beams, and I can do the same for the shells. So yeah, let's see, display. All right, then there was a question about load combinations. Okay, I will just open another FEM-Design tab, as I don't want to ruin this one. And I will just quickly show you how you can manually input your load combination, so I don't forget. So you see here I basically write load comp1, then the type of load, ultimate, accidental, serviceability, etc., right? And then the factor. And I write 1, not 11, 1.5, etc., 1.35. And here there will be a drop-down menu. Now it says only seismic because I don't have any loads. But in your model where you define the loads, you will see all the loads, and you will select, like 1.35 permanent, 1.5 live load, 1 wind load, or I don't know. So this is how you create your own load combination, and then you go and just click load comp2, and you do the same, and you do as many load combination as you like. But as I said, I just generated all of them you can generate less. You can generate only the ultimate. You can generate only the serviceability. So it's not mandatory for FEM-Design to generate all the load combinations. Yeah. So yeah, moving to our colleague with the foundation. This is the soil. So you will design the soil first, and then the rest of the structure. And yeah, it's a bit more to work. Let's see. Is it possible to get a recording after the webinar? Of course, you will get a recording and the recording link. But just so you note, because this is like a very, often webinar that we do, there are already recordings on the YouTube which are uploaded, and introduction to FEM-Design, which you can search by. And you will find maybe not necessarily the same structure, but more or less the same. So I remember that in the last webinar that I did, I also showed the audience about how to import and correct an IFC file. So, this is how you basically import an IFC file. You just select what you want to import from the IFC. You can select or unselect in the window. And yeah, the materials, it depends how much was mapped and how detailed was the IFC that you are trying to import. And basically, yeah, this is it. In that webinar, we worked a little bit with the adjust model, how to correct an IFC file. There are at least 2 or 3 webinars treating this subject alone. So yeah, as I said, use YouTube. It's really good. We have all our webinars recordings there. And if you can't find something that you are searching for, you can always use our support. So if you go to StruSoft.com, for example, and you go into the resources and you go into the support, you can create a ticket. Like here, you can view your ticket from a list. And yeah, our support will definitely answer, or you can send us the sales representatives your questions, and of course, if we have time, we will jump directly in a Teams call with you guys and assist you. So yes, I encourage you to just test it yourself. And yeah, I see somebody is asking about the Excel tables. Now, of course, we can do that as well. There is this list that we can use in a tab, or you can just go to the documentation part and maybe use a template. It will automatically install some templates about how to do the documentation. Let's see, 3D plate RC. Yeah, just take this one. I just took a random one. So basically, I have in my data one of them and create the documentation of that. And add part again to another webinar. I think it will show you how, for example, how it will automatically update your documentation, even if you had to rerun the analysis, and all the results will be updated, including the ones in the pictures and so on. So yeah, and this documentation as well is not mandatory to be this long. You can make it as long as you want. So I guess each company will do something which is, you know, tailor-made for their own needs. So yeah, you got, like, you know, the overview, the materials, etc. You can add as many pictures as you like, and yeah, you can take all the results one by one. You can do as they do here. You know, this is dynamic, so you can zoom in at any point. So yes, and you know, here are some of the tables that yeah, you can visualize. So yeah, thank you for attending this webinar. I know you still have a lot of questions since you are just beginning on this journey, but rest assured that we are here to assist you and to provide you with the best possible support. Just don't be afraid to send us your questions, and we will do everything in our power to answer. This being said, I will see you guys in the next webinar, and yeah, I hope you like it. Have a good day. Bye bye.